It's no good being able to describe transformations if you can't recognise in the notation what has happened. So here's some examples that I'll work through to hopefully help you to see a bit better how to do this, which is the hard bit. So first of all, we don't want the y notation. We want to use function notation, not equation notation, so that we can see what's going on. So f of x is x squared. F of x is 3 to the x. This is our function that we're starting with. F of x is x cubed plus 2x squared minus x plus 1, and finally f of x is root x. So this function notation is really good for recognising and describing graph transformations. Right, now we need to look at our transformed function and see if we can recognise what's happened. So this is a classic one, completed square. Note, this is the completed square. And what's happened? We've done f of something and ended up with x plus 3 squared now instead of just x squared. So that must have been x plus 3 in there. And then there's a minus 2, so there must have been a minus 2. So we're just moving into the function notation, and then we can describe what's going on. This is a translation, and it's going to go left 2, down 2. Or you could use vector notation and say it's a translation left 2, down 2, like that. Okay, the next one. This looks really complicated because the 3 isn't even a 3 anymore, it's a 9. But that's okay because look, 9 is just 3 squared. So 3 squared all to the x, that's the same as 3 to the 2x. So now it's kind of obvious what's happened. Instead of f of x, I've done f of 2x. Because f of x is 3 to the x, so f of 2x is 3 to the 2x. So that would be 3 to the 2x. So that, we know, is a stretch, because it's inside. Now, anything inside does the opposite of what we think. So that plus 3 was actually... Sorry, oh, look, I wrote left 2. That's going left 3. Something wrong with my brain. Left 3 down 2, minus 3 minus 2. Sorry about that. Hopefully you actually noticed that and wondered what I was talking about. So this second one, this is a stretch, but inside does the opposite of what we think. So it's not scale factor 2, it's scale factor the reciprocal of 2, 1 over 2. And it's inside, so it's stretching left and right. So that's parallel to the x-axis, and then it's the y-axis that kind of gets fixed in place, so about the y-axis. Okay, third one is tricky, but you just kind of have to look at it and think, well, what am I looking at here? F of what? And then what? Is anything, like with the completed square, what has been put into this function here to produce the thing that I'm looking at? So let's see what happened. Well, here's something really obvious, which is that minus x has somehow become plus 2x. So what I'm thinking is that what's gone into the function, instead of being an x, is a minus 2x. So here we put minus 2x, here we put minus 2x, here we put minus 2x. So what would that look like? It would be minus 2x cubed plus 2 lots of, so I'm just using the definition of the original function, plus 2 lots of minus 2x squared minus 2x plus 1. That's f of minus 2x. So that gives us what we want, because minus 2x all cubed is minus 8x cubed. Then here we've got a minus being squared, so the minus and the minus cancel, giving us 4x squared, but 4x squared times 2 is 8x squared. We've got a minus and a minus here making a plus, so that's right, and then the 1 on the end isn't affected. So what's happened is f of minus 2x, so this would be two things, they're both inside, so it would be a reflection, that's what the minus sign does, over the y-axis. And it would also be a stretch but not scale factor 2 because it's inside the bracket. So scale factor the reciprocal of 2, which is a half. Scale factor, I didn't write scale factor, scale factor a half, and it's exactly the same as the one above because it's going left and right parallel to the x-axis about the y-axis. Okay, last one is what's happened here. So we've got an x minus 1 in there instead of an x, so that's f of x minus 1, but then there's a plus 2 as well. So this is like a completed square. It has gone right 1 up 2, so that's a translation, right 1 up 2, or you could write it in vector notation, right 1 up 2.